Yeah, today's section is about approximation of integrals. So first of all, let's discuss the following problems. It's the integral of x plus 4 and the x squared plus 2x plus 4 plus 5. Right. So look at the denominator. It's x squared plus 2x plus 5. You're not able to factor it. The reason is that it does not have real zeros. Right? So this never be 0. So how do you do that? Well, if it's never be 0, then x squared plus 2x plus 5 can be written as written in this form. So actually is x plus 1 squared and plus 4. Okay? So that's the denominator. Therefore, you can simplify, let u to be x plus 4. Right? Then so du equals dx. So the integral becomes, oops, the integral becomes the denominator is just u squared plus 4, right? Good, looks good. The numerator is going to be x plus 4, so wait a minute, that's just x plus 4. Oh, no, x, so it's x plus 1, I'm sorry, this should be x plus 1. So the numerator is x plus 4. So that would be x plus 1 plus 3. So u plus 3 dx. Okay, du. How do we evaluate this integral? Maybe you have to separate it. That's pretty standard. Okay, so you separate it. So the first one, you have to use another substitution. So the antiderivative will be u squared plus 4. When you differentiate, get 2u, so I have to put 1/2 here. So sometimes, you can write down the answer directly. Okay? Otherwise, you just let w to be u squared. You can let w to be u squared plus 4, blah, 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 you can go through that. Okay? The second part, yes. The second part, we still have to find it's constant here, right? So maybe let me do all the substitutions step by step. Both you use a different substitutions. Okay, so this one you get w equals u squared plus 4. So dw equals 2u du. Okay, so the integral will be w 1/2 dw. The other one I'm going to use. Let's also use a w. Say that x doesn't matter. It's going to be 2w equals u. Okay? Then the integral will be 2w, so 4w squared plus 4 and the 3, and the du is going to be 2 dw. Okay? Well, it'd be easy to be confused. I'm not going to use w. Okay? It's easy to be confused. So use any let's say s, so ds, and that's give me 4s squared. Okay. Okay. So this side we 1/2 natural log of absolute value w. The other side, let's take a constant out, 3/2. So this will be integral of x squared plus 1. Will be arctangent s plus c, right? The derivative of arctangent s is going to be 1/s squared plus 1. Okay. So now, let's go back. W is going to be u squared plus 4. Okay? And arctangent, what is s? S is half of u plus constant. right? So this is the same u, and u is going to be x plus 1, so we go back to x plus 1 square plus 4, and plus 3 over 2, arctangent x plus 1 over 2, and plus constant. Okay. So not all the polynomial quadratic function can be factored as product to linear terms. If it has no zeros, you cannot do that, right? So what we're going to do is study section 7.7. It's about approximation integration. Okay, we want to estimate the integral. But first of all, recall the definition of the integral, right? The definition of the integral says that if we are given, let f be a function defined on the interval from A to B, and you can take an arbitrary partition, right? And also an arbitrary point in the ith interval. I think this is the I minus 1, and here's I. Then the integral of the function, we have to recall the definition of that, right? This is going to be, so delta xi approaches 0. This is a Riemann sum. Okay, so what is delta xi? Delta is this because those subintervals do not have an equal length. Okay, so delta xi is going to be xi minus 1. So the size of it. Right. So if you want to estimate the integral, you just use the Riemann sum. Okay. Now then there are many choices for that. Okay. But in most cases, you can choose the partitions of equal size. So if the Riemann shows that, okay, Riemann's works that if f is continuous on the interval from A to B, then this integral exists. That means among all those partitions of the subintervals, as long as the size of the subinterval getting smaller and smaller, they approach the same number. So if this exists, moreover, you can use a special partition to evaluate. So this is so the integral value is going to be limit as n approaches. See the difference here. The points I still can choose an arbitrary point, but the delta x will be the same. The delta xi. So because we use the special partition. Okay, we use a special partition as here from A to B, and this just even, right? x1, x2. So this xi is going to be A plus I delta x. Okay. Because of that, I get the first approximation for the integral. Okay, the first approximation is the integral is approximated by this. Okay. Then we come to the first when this is arbitrary, right? We call the midpoint rule. or just midpoint rule. Okay, so it says that that means you can choose I star is going to be the middle point. Okay, the middle point, which is xi minus 1 plus xi. Okay. Then the integral of the function is going to be this middle point, and this middle point has a special notation called xi bar. Okay, so then just xi bar and delta x. So this coming from the definition of the integral, okay? Because the limit of this Riemann sum approaches integral. So if you choose more special points and xi star, then you can get approximate, you can estimate. Now, the so-called trapezoid rule is slightly different. Okay? The idea is we understand the geometric meaning of the geometric meaning of the integral. Okay. So we look at the picture here, the graph. Here's A and the B, right? Right. So you get x. Here's x I minus 1, xi. So the integral. What is the meaning of the Riemann sum? The Riemann sum here is the middle point. This is xi bar, right? So actually, what we did here, we use a rectangle to approximate the area. Approximate. Approximate. This product. Okay, just the area of this rectangle. And the geometric meaning of this integral is going to be the area of the region and the graph y equals f of x. Okay. So the left hand side means the area of the region and the graph. Okay. But the right hand side is just the area of those rectangles. Okay. So we can let's do something different. Okay. So the sum of the area of this rectangle can give you a very good approximation of the area of the region. This is what it says about the above identity. Okay. The sum of these rectangles, okay, we use a midpoint, okay, and you take the midpoint is give you a better estimate. Okay, if the function is increasing or decreasing, then if you choose a midpoint, I think the area of this rectangle using the midpoint, and it's almost equal to the area of the region and of the region and the graph. Okay, but once you use this geometric picture, then you realize that maybe the trapezoid is going to give me better estimate, right? So let's try to do that. You're not using Riemann sum. Let's just use a geometric picture, right? So this is the idea. So let's look at the trapezoid. It's the same picture. This is A. That's a B. Okay, and this is xi minus 1 xi. So instead of using middle point, I use a trapezoid. This is trapezoid. Now, what is the area of this trapezoid? The area of this trapezoid, so gives a better estimate of the region, area of the region of this graph. So the area of the trapezoid, the i's trapezoid, right, is going to be the average, the height, right? Half of f of xi, minus 1, f of xi, right? Right? The average value of the two bases times delta x. That's it. So this is also a good, this is probably even better approximation for the area of that region. So add them together, this is going to be estimate, and instead of fxi star, and I use this sum. Next. Okay, so this is called the trapezoidal rule. That's the idea. Because it's coming from the geometry picture. Okay? And in the book, it's also discussed the errors, and then the guy called Simpson. You know, you watch a movie when you're young, right? Simpson. I don't know, it's the same. It's not simple. It's a common last name. Okay, and he decided, okay, trapezoid looks fine, but if I can choose two nearby, two strips, yeah, two strips, then you probably can use a quadratic function to approximate. Okay, if you use a quadratic function to approximate, then you will get much better estimate for the area of the red region. Okay, so yeah, let me describe the region for you. This is going to be yeah, we're probably not going to cover this. This will be, so here's a point, okay? Here's, before we do talk about this, we need to see, we are familiar with the area formula for the trapezoid. So now I'm going to give you another formula. This is supposed to be, okay, if this is h, that's the h, okay? That's a picture. And then if this is a quadratic function, y equals ax squared plus bx plus c, it's passing through these 3 points, right? If the height here is y0, y1, y2, right? Then the area of that region you can calculate, okay? The area of that region is going to be 1/3 y0 plus 4y1 plus y2. Okay, so this is the exact area of the quadratic function. We can calculate that by integral. So suppose, yeah, this quadratic function at those 2 points, yeah, is the height here, is y0, y1, y2. Then you can figure it out as an area. Okay, so now we're going to use this picture to solve the problem. I think first of all we must have an even number of subintervals. Okay, so even number of subintervals. So let's look at the picture. Right. So I'm going to choose. This is A. That's a B. Right. Because every time I have to choose a pair of that. Right. So this is x0, that's xn, okay? Then if n is even, right? So that's the reason we have to even, because every time we have to compare a pair of pair of the strip, right? And different colors, and I can put different colors. That's this idea. And you can even use more general polynomials to do better estimate. Okay, so n must be even in order to do this kind of partition. Okay, n is even. Then you will see that. Okay, so let's label it. Right, this is going to be y0, y1, y2, y3, y4, y5. Right, keep it going. So the integral of the function. Okay, let's write down sentence rule. So this is a okay. How do you estimate, right? So the sum of those areas is pairs, right? So it's going to be h is going to be delta x, right? So it's 1/3 delta x. And the first part is y0 plus 4y1 y2, right? And then you have to begin with y2, 4y y1 y2, yes, that's right. Then y4, right? And just keep it going. The last term will be y minus I think yn, and go back to y4 n minus 1 and n minus 2. So you have to, this is a good estimate for the area of under that region. Okay, now, but when you combine them together, you find out you find out the formula here, y0 and 4y1, then you only have a y2, double y2. Okay, and you have 4y3, and you have a double y4. Just keep it going like that. And the last term is 4yn minus 1, yn. Okay, so what is yi? Yi is nothing but the value of the function. Okay, yeah. So yi is going to be f of x. Okay. So this is a simple issue. Okay, it's harder to write down general. Just put it in one single. It's harder to put it in one single sum. So that's why I have to list all of them. So the idea is the second or third approximation comes from this geometric picture. Okay, and that's if you understand the meaning of the integral, which is sort of the area of the region under the graph, then you can approximate the area of each region and add them together, which is a strip. Yeah, and add them together, you get good estimate for the area. Okay, which is the integral of the function. Right now, I cannot test you. Use a calculator, right? It's not allowed. Actually, we are going to have just pass the new policy for all the departments of school science. It says that during the quiz exam, no electronic device should be used. Okay, smart watch should be removed and put in the back, and cell phone also should put in the back. Okay, let me repeat again. And for whatever the reason you take it out, okay, the test of quiz will be invalid. We don't accuse you of cheating, but that will become invalid. Okay, that's up to instruct whether he's going to give you makeup quiz or test. It's not guaranteed. It's up to the instruct. Okay, so so must review. So because the reason is it's harder for the instructor to monitor. Okay, so if you are waiting for some emergency phone calls during the exams, you have to tell the instructor in advance. Okay, you're not allowed to put the cell phone without telling the instructor. Maybe it was telling the instructor. Maybe you can set to the silent, put on the corner of the table, but you have to tell the instructor first. So when it's vibrating, you know some message is coming. So that should be okay. That's case by case. Okay. All right. So how do we do the problem like that? I wanted to write down all the terms. Okay. I want to just write down all the terms without evaluating them. Okay. And for example, yeah, we always have. You don't need to estimate because if we are able to write down all the terms, and you can do the problem by using calculator. So let's take a look at the following problem, and this is a good problem. When just consider the integral, right? From 0 to 1 e to the x squared dx. Nobody can evaluate this integral, right? Right. You can, no matter what method you're going to use, maybe computer, you can type it in. Okay. Why you're not able to use this, evaluate this integral? If you have to do that, surprise to me, you have to use the complex numbers. Oh, what's nothing to do with complex numbers, right? Why we have to do that? Yes, if you have to, complex numbers are created by human beings. Real numbers just existed, are created by the God. Okay, that's the difference. Real number, that's a real, you can touch it, see 1, 2, 3, 4, pi, those are all the real numbers. And here, integral of x squared, that's just, right? It's x takes real values. But if you want to evaluate this integral, you have to go beyond one dimension to two dimensions using complex numbers. So we're still able to estimate. How do we write down all the possible estimates? Let's let's write down all the formulas using midpoint rule. I'm going to let's set the n to be 4. Okay, make it easier. So delta x is going to be 1 minus 0 divided by 4. It's 1 over 4. Okay, so you get x. Okay, you got x0, which is 0. X1 is a quarter. X2 is going to be 2 over 4. X3 is going to be 3 over 4. X4 is going to be 1. Okay, so you list all of them. And for the midpoint, you cannot use those numbers. Okay, for the midpoint, x1 bar is the midpoint of those, the average value of those two. So it's going to be 1 over 8. Okay, x2 bar is going to be 1/4 plus 2 over 2. So it's going to be 3 over 8. Okay, and x3 bar is going to be 5 over 8. X4 bar is going to be, I think it's a 7 over 8. Okay, so those are the midpoint. So then I write down the formula. The midpoint rule. The midpoint rule gives you the estimate of this integral, and the computer can tell you which is better. Okay, so how do you write down the formula, right? So there, it is going to be integral 4 I from 1 to 4, right? F of xi bar delta x. So don't put f there. You have to use a specific number. So you have to write down, the first step, you have to write down f of x1 bar, f of x2 bar, f of x3 bar, f of x4 bar, right? And then delta x. Then you have to put the details there, right? So f is going to be e to the x, right? So what is the first point? It's 1 over 8 squared, and e to the 1 of 3 over 8 squared, e to the 5 over 8 squared, e to the 7 over 8 squared, and the delta x is a quarter. So this is what I want to see. Okay, this is what I want to see. Okay. Then let's go back to trapezoid method. Trapezoidal. So trapezoidal, right? Because each time it is going to be for, if you remember the original formula, right? Okay, this is the original formula. But if you want to write down a little bit more details, this can be f of x0 and twice of x1, twice of x2, I think twice of x3, then the last term. All the terms in the middle twice. And delta x is 1 over 4, so divided by 2 is 1 over 8. F of 0 is going to e to the 0 square, e to the 4th square, e to 2 over 2 square. Okay. So I want to see something like that. You put all the details. That's trapezoid. Trapezoidal. You can estimate, right, each of it. Right. Okay. This is actually the y0, y1, y2, and yeah. And then we come to Simpson's rule. Okay. Simpson's rule, I said that I cannot use a sigma to describe it. I know the coefficients are could be 4, 2, 4, 2, right? And the first one, that's 1/3, yeah. So let's write down the details. Right? This is going to be delta x over 3, right? And here will be the first one, y0, then 4f(x1), and 3f(x2), and 4f(x3), then f(x4). Okay, so those are all the terms. Okay, they're slightly different. Actually, you only have two sets of that. Okay, and this will be separated for f(x2) and f(x2). So this f(x) will go to the first group, this f(x) will go to the second group. There are two sets that each represent the area and the quadratic function passing through those 2 points. There are 3 points, yes. So the graph could be, let me check, I will write down the graph, okay? So 3, delta x is 1/4, so it's 1 over 12 actually, okay? And this first term is e to the 0 square, 4e to the quarter square, 2e to the 1/2 square, and 4e to the 3 over 4 square, and e to the 1 square, okay? Let's understand the picture again. Okay. For the middle point, let's look at the picture, right? y equals e to the x. When x equals 0 to 1, when x equals 1, e to the x is e somewhere here. It's going this direction. Okay. Okay. So you have a 1, 2. Let's we divide it into 4 sub-intervals. Right. So the midpoint, the midpoint, we use the midpoint, right? The integral is going to be area of the region. Okay. So so the area of the region, the integral is going to be the area of the region under the graph. This is the y equals e to the x squared. Right? So the integral from 0 to 1 e to the x squared dx is going to be the area, right? And oops. Yeah, I don't know. The electronic current is quite different from other classroom. That have impact on my screen actually. When I write, it never shows up in another place. Funny, yeah. I thought my computer is broke. So this is the exact area of under the graph. So the midpoint. This is the midpoint. So the area is approximate by those rectangles. So now let's look at the trapezoid, right? Trapezoid, it's going to be almost much better. You can see that. Come on, please go away. Okay. So this is a trapezoid. Okay. So it looks like a bat. I don't know. But for increasing function, midpoint is also pretty good. Yeah, this is trapezoid. So the area of this trapezoid could be very close to the area of the region under the graph. For the Simpsons, I think, yeah, it's still hard to draw. Actually, we have two different. I'm going to have two different colors. One is this. Other one. Right. So we're going to have for every 3 points, there's one unique quadratic function. But this time, yeah, maybe the quadratic function looks like that. I don't know. Okay. So it's hard to expect. Yeah. So the area of that region is approximated by the area of those 2 regions, and each region is under this very specific function. Okay, graph the quadratic function. Okay, as long as you know it's the height of those 3 points, there's a unique quadratic function. Okay, whose graph passing through that point. So this is a so it's harder to tell, but for most of the functions, I think the simpleton's rule gives you better estimate than the trapezoid rule. The trapezoid is kind of a linear, then the midpoint rule is comes from the definition of the integral. It's not the best estimate. Okay? In earlier days, people don't have a computers, did not have a computer, so they have to estimate the integrals. Even later on, we have a computers right now, but you still have to write the programs. You have to understand the computer. What the computer does is not like evaluate the integral like you did. Okay, you find antiderivative and then plug the numbers, evaluate at two endpoints. But like e to the x squared, you're not able to find the antiderivative. So you have to estimate. So if you write a program for the computer, okay, and you can write three programs. One is called the midpoint rule, and one is called trapezoid rule, and the simple rule. And the computer, you can choose a different rules, applying to the estimation. And the computer can do very fast, right? It's getting faster and faster computation. Okay, so in a few years later, if we can design, make a super fast computer, we can design like someone similar to a human being. Okay, so so he or she can do lots of things. Okay, clean the house, cooking the dinner, everything. Okay, so but you have to do the computation very fast because when you communicate with that person, he has to react quickly, right? If you go on internet, you get design some, but that's still not fast enough by the computer, basically. Right? So we can then we have three programs here. You can write three, and you can tell the difference. For more weird functions, and they can tell the difference. Simpleton rule is much better than as a two rule. Okay. So we just briefly understand the material here. We don't need to do the computation, as I said that, but you should be able to write down the four terms for each rules, okay? And you understand how do we get those rules. What I did not do is here is to find the formula for the area of that region. Okay, if you have a quadratic function passing through the 3 points, if you know the height of each of them and the area formula of that region, particular region is given by this. Okay, and the trapezoid, we know that, we learned that in the middle school, so everybody knows that. Okay, so that was the issue about how much you should know in the middle school. Okay, and I saw some kids are smart. They're the 6th grade, already taking 8th grade math, and say, what kind of math are you studying 8th grade math? Well, they learn these formulas, but that's an issue. I don't like the idea to jump to the high level math. They have to go deeper, understand more, not just learn the formulas, right? Not just learn the formulas. Formulas you can learn matrices. Some kids I can teach them quickly. What is a matrix? What is differential equations? But just memorize few terminology is not enough. Okay? So someday when you have a kid, when you get grade report called A, oh my, it's get A, but you have to test it. Well, what is it? What does that mean? At different schools and different meaning. Okay, so the best way to check whether your chart is good enough in math is to go online, print out the math computation test. That's nationwide and statewide, and this is supposed to material covered by all the schools. But there's some schools, then test it. If his grade, it's almost 8th grade, then it's ready to look at the test to see how many problems I can do. It's no. That means it has knowledge, but it has no skill to solve the problems. It's not good. Okay. Yeah, in the United States, at every level, there was a math competition. In 4th grade, 5th grade, they call it congruent math contest. In middle school, the more math counts. High school, then have high school level. IUPI also sponsors math competition